Hello, I am Kumar, Vembu, Swathi, and I am going to be presenting to you my final year project. My final year project focuses on machine learning for attacking gesture based phone unlocking. We are going to look into this question. Is it possible to analyze and combine various side channel information to guess whether a particular digit belongs to a user PIN code or not? The flow of my presentation is as follows. So first we look into the problem statement, move on to data pre-processing, next we go on to model training, and finally look into results and conclusion. So there are over 6.6 billion smartphone users in the world, and our smartphones are used for various day-to-day activities like tracking user health, performing net banking, and so on. Our smartphones are also equipped with various devices like cameras and sensors. These devices, however, leak information and therefore are known as side channels. So, if a PIN code of a smartphone is compromised using these side channels, one can obtain sensitive data from the smartphone. We look into different implementations of retrieving PIN code using these side channels. ITEL and Gaze Revealer basically use camera information and eye movement to retrieve the PIN code. They have drawbacks like light, spectacles, and angle affecting classification accuracy. There Goes Your PIN code uses sensor information to retrieve the PIN code and has drawbacks that include using your offhand and keeping phone on surfaces like tables. Therefore, our model combines both of these side channels in order to retrieve the PIN code. This is an example of how gaze tracking is performed and coordinate data is stored as shown on the right. Next, we move on to identifying the pattern using our coordinates. We can first note that the keypad shown on the left is flipped. This is because whenever a video is saved using the camera, the video is mirrored. Therefore, for PIN code 1030, we can see that it starts on the top right, goes towards the bottom for digit 0, goes to the top left for digit 3 and comes back to the bottom for digit 0. So with this we can see a pattern can be obtained using coordinate and visual information and can be used for model training. Next, we look at how our phone is equipped with a variety of sensors like accelerometers, gyroscopes, temperature sensors, proximity sensors, and so on. So the example of accelerometer values are shown on the right. We then see that our data has a total of 43 features, including these sensor and camera information. Data is collected from 100 different participants where they each type 100 different PIN codes. That means they have 10,000 different samples. After data pre-processing, we now have only 9.8k samples. Next, we see that our data is split into train, validation, and test in the ratio of 60:20:20 respectively. For data pre-processing, a variety of steps is performed as shown on the right. Cleaning, understanding, and deducing information from the data is a crucial step for training our model. So the one thing we look into in data pre-processing is saccades and fixations, as it is important for future work. A fixation refers to a visual gaze on a specific key, while a saccade refers to a switch between two fixations, that is an eye movement between two fixations. So a breakpoint can be used to represent these fixation and saccades because they are represented whenever there is a structural change in data. So this will help us identify the shift in gaze between the digits of a PIN code. So next we answer a very important question. So do each of us type the PIN code in a unique way, or do we all type the PIN code in the same manner? So with this, can we find the number of ways in which we can type our PIN code? Yes, with the help of clusters. For this, a k-means clustering algorithm is used. So the distribution of PIN codes for the same person between the three different clusters are shown over here. For example, all the PIN codes typed by person A belong to cluster 0. All the PIN codes typed by person B belong to cluster 2, while all the PIN codes typed by person C belong to cluster 1. So from this it can be seen that maybe if a person types all the PIN codes in a certain way, they can be grouped into the same cluster or group. So if a person has been sitting in the same light sensitivity area, or if the person is using a certain position to type the PIN code, our clustering algorithm is able to identify all of that and group that into the same cluster. So to verify that the clustering algorithm works for the most of the students, the number of students for whom the count of the max cluster is double the count of the second max cluster is 85 out of 100 students. So that is, our clustering algorithm works for more than 3/4 of our participants. So next we move on to model training. So there are two big setups for model training. One to determine whether a digit exists or not, and secondly a temporal model. So to recap, we have train, validation and test data, and only the train and validation tests are used for our experiments, and the test data is set aside. Moreover, the results in the experiments shown after this are given with cross-validation. So the first setup is to determine whether a digit belongs to a particular PIN code or not. The baseline for this model is around 34%. The calculation for the baseline is shown below. Next, we can see that the data might be imbalanced. That means the model might determine whether that the digit does not exist majority of the time, and for this purpose we perform balancing. Class weight outperforms the rest of the balancing techniques, and the results are shown here. As seen, our accuracy performs 20% over the baseline for digits 0 and 1, and from this we can see our objective is achieved. So next we move on to improvement of results, which means we train a harder model, that is to guess the number of occurrences of a digit. So for example, if the PIN code is 1003, there are 2 zeros. So the model predicts the count 2 for digit 0. So now we can combine, setup B is done to combine this with setup 1. That means if there are count 1 and 2 and 3 or 4 of a digit, that means the digit exists in the PIN code. So the results for this is shown, and we can see that setup B outperforms setup A and is again 20% over the baseline. Next, we perform some model enhancements, and we can see that padding with length 381 along with feature selection of 14 features produces the best results. Next, we can see that the need of a temporal model is to see if a pattern can be identified by gaze direction. For the temporal model, the keypad is divided into 3 different zones. This is vertically, but it is also done horizontally. The baseline for this model is around 11%. Finally, we can also note that the temporal model can be trained for 3 different time steps. For example, for PIN code 1030, at time step 1, the PIN code goes from 1 to 0, that is from zone 3 to zone 2, and this is what our model will be guessing. So the results for this temporal model are shown, and a variety of experiments and enhancements were performed, and the results are only shown for the best setup. So the temporal model is much harder to train and therefore needs more enhancements that need to be performed over the base improvement. However, our base improvement itself performs above the baseline. So we can see that the results are shown for the test data set that we kept aside, and this is shown for both the base model and the temporal model. Finally, a sample output from our model is seen. So for PIN code 4753, we can see that the column 4, 7, 5 and 3 contain the digit 1. This means that these digits in fact belong to the PIN code. Our model outperforms gaze revealer for half the digit. So we can see that gaze revealer also does not specify whether balancing is done, and a gaze revealer also performs an enhancement method using saccades and fixations. However, we can look into this in our future works. Next, we conclude by seeing that our objective is achieved. That is, we can combine various side channel information to guess whether a particular digit belongs in a PIN code or not. Finally, our future work can focus on recovering the entire PIN code sequence itself. With that, we come to the end of this presentation. Thank you.